Okay, we are doing Aldol condensation reaction, and this is the question. So the first step is to make an eno. Okay, so let's start. So since it is acid catalyzed ionization, we have something which looks like this, right? Um, we have something which looks like this. This is our question. So we are starting the process by doing the acid catalyzed ionization. Okay, so under acid catalyzed ionization, the oxygen tends to get the hydrogen. So it will come here and attack and get the hydrogen. This bond which is holding the hydrogen to oxygen, it will break. Excuse me, to break. Then you produce water which is H2O. The product will be like this. You only put the hydrogen where you got it. Yeah, so you put your hydrogen here. You have seen here there was no the oxygen attacked and got the hydrogen. This is the hydrogen which it took. Then this bond break, it has two. This oxygen has two hydrogens, so we form water. The next step, it is to use water to get the hydrogen from this carbon, right? So let's just expand this carbon. This carbon has 3 hydrogens, so I'm going to put 2 and a hydrogen, 1 hydrogen. I will extend the bond so that I show the reaction. So here we have our H2O. So the oxygen will come and get and attack and get the hydrogen. The bond holding the hydrogen and the carbon will break, sending electrons to carbon. So you end up forming something which looks like this. There's a hydrogen here, and this part will remain the same. Hydrogen here, double bond to oxygen, just like that. Then this carbon, it will have a negative charge. Since now it has a negative charge, right? The carbon that has a negative charge, it will come and attack on this oxygen. That's cyclization. Now it will take place. Okay, so we have 1, 2, 3, 4, 5 carbons. So I'm going to draw it like this: 1, 2, 3, more like a car house. Yeah, so 1, 2, 3, 4, 5. On position number 5, you have double bond to oxygen and a bond to hydrogen, right? Then on position 1, that's where you have the negative charge, right? Okay, so on position 2, we have a double bond to oxygen with a hydrogen. Then on position, what now? Okay, 2, we have that. What else? Okay, that's all right. So this oxygen, it will at this carbon here, which has a negative charge, to attack on this position 5 to result into cyclization. Then this bond of this oxygen, it will snap one bond of it, sending electrons to oxygen. Then oxygen will have a negative charge, and we left out something here. The hydronium came out, which is plus. After it got the hydrogen, this water got the hydronium came out. Then we have an ion. An ion attacks on the 5th carbon, as it is attacking, it is forming a cyclic ring. Then here you show how it is being formed. Then at the end now, that's why you show now like it has what bonded. It has bonded. So you can show the hydrogen. You can show the hydrogen, but on this case it's not even important, so let's just leave it like that. Okay, what else do we have? We have a double bond at position 2. So if we say this was our 1, 2, 3, 4 and 5. So in position 2 we have the double bond to oxygen, which has a bond to hydrogen. Okay, on the next step we have proton shift, where the oxygen with the lone pairs of electrons, it will come and get the hydrogen here. Then the bond holding the hydrogen and the oxygen, it will snap, sending electrons to the oxygen. The end product, it will be like this. It will be like this sign OH here. So just write proton shift. Then you put negative hydrogen ion, positive hydrogen ion. That's your proton shift. Okay, so on the next step we are going to use water, H2O, right? And look at this side, it is the longest distance for me to meet with this oxygen, right? But this side, it is the shortest distance for me to meet this oxygen if I'm coming from this oxygen, right? So that means here there are 2 hydrogens which are acidic, but we'll only get 1. So when we get 1, this bond will, sorry, I was a bit too fast. Let's not go here first. Let's introduce a hydrogen to this oxygen so that we make it a good living group, right? So we have the hydronium, which is H3O positive. So I have just expanded it so that it is more in detail. So now the oxygen, it will come and grab the hydrogen here. The bond will break, right? Then after that we'll have this compound, will have what? We'll have a water molecule here, more like I bonded to the same compound. So what are we going to have? Something like this. Double bond to oxygen, right? Then here we have OH2, which is now a very good living group, right? Then on the reaction we produced water, so water is coming out. Okay, so now let us reproduce our hydronium. So our hydronium will come here, since I've already talked about the acidic hydrogens. So now let's start the process. So the water now, it will come here. The water will get the hydrogen. The bond holding the hydrogen, it will break, sending electrons on this bond here. Then this bond holding the water, good living group, it will snap, sending electrons to oxygen. So here water has gone out and the hydronium has gone out. The end result of this whole reaction, you end up forming a double bond here. Then an oxygen will be bonded here. What is coming out? It is hydronium and water. So hydronium, it is H3O with a positive charge, and plus, you say plus H2O. That means you are done.